Morning, everyone. Yes. Good morning, everyone. Now, I hope my video and audio is clear for you. Yes. If there is a still problem, please raise your hands. Yeah. So, initially, have been discussed about. Yeah. Okay. So now I hope there is no noise also. Yeah. Okay. Fine. Okay. So now let's come to the session. In yesterday's class, we have been discussed about I don't know, a lot of lagging is there. Some sort of problem is coming. Yes. Okay, so in yesterday's class, we have been discussed up to this point. We discussed about the single point observation and we discussed about the 2 point observation, about how to determine the maximum and average velocities. So now let's see a question based upon this one, the previous gate question. I hope, is there any other problems now? What about the voice? Does audio is clear and video is clear? And what about the sketchbook? So if there is any problem, you can say to me right now. I hope everything is good now. Yeah. Okay, fine. Let's come to the subject. So let's see a question based upon this. Yeah. If you can observe, whatever the question I'm showing you here, it's one of the previous GATE question, GATE 2012. And now I want to solve this question. Have a look about this question, please, everybody. So now, you see, the top width and the depth of flow in a triangular channel, the top width and the depth of flow in a triangular channel were measured as 4 meters and 1 meter. So in a triangular channel, see, I have given you the channels as a rectangle, and I told you there are a different type of channel sections, and that will be discussed in within a few minutes also. So as of now, and I said you, in the case of pipes, the cross section is going to be almost circular in shape. But in the case of the open channels, the cross section may be rectangle, triangle, trapezoidal, semicircle, or circle also. So now they have given you the triangular channel. This is a triangular channel. Water surface. Okay. And I have given you the top width. Whatever this is nothing but the width of the water. We can represent it as a top width, the T. The top width is given as a 4 meters. And you know the meaning of depth of flow section. From the water surface to the deepest point, I told you the depth is nothing but from the water surface to the deepest point. What is the depth of flow given? So depth of flow is going to be 1 meter. Now, the measured velocities on the center line at the water surface at a 0.2 meter and a 0.8 meter. At a 0.2 meter and a 0.8 meter. See, this is section, right? Cross section. And if you go for the longitudinal section, then what they're mentioning is, if this is a water surface, this is channel bed, what is the total depth? The total depth is going to be 1 meter. The total depth is going to be 1 meter. And whatever the measured velocities on the center line means this is the center line. Yes, the center line means that the depth is going to be 1 meter, right? And the velocities they have measured as, so at a depth of 0.2 meters. See, if y is equals to 1 meter, if y is equals to 1 meter, then what is 0.2y? 0.2 meters. And what is a 0.8y? 0.8 meters, right? And whatever the velocities they have measured as a 0.6 and 0.4, which means the velocity at a depth of 0.2y is nothing but 0.6 meters per second. 0.8y is given as 0.4 meters per second, where y is equals to 1 meter. So if y is equals to 1 meter, then at a 0.2 meters means 0.2y, 0.8 meters means 0.8y. Then using 2-point method of velocity measurement, the discharge they're asking. What is the asking? Discharge. Look, I have given you the triangular channel. The channel is going to be triangle, and I have given you the top width and depth of flow. Apart from that, I mentioned you the velocities. So now, once I know this one, then I need to find out the discharge. So I want to find out the discharge. What is the discharge? From the continuity equation A into V. And I told you, for analysis, always average flow parameters should use. Flow parameters should use. for the analysis, for the sake of analysis. So we are going to use the average of parameters, and what is nothing but we average R naught. Yes, and you know that from the 2-point observation, what is V average? V average is nothing but velocity at point 2y plus velocity at point 8y by 2. What is velocity at point 2y? Point 2. See, you know that the velocity distribution looks like, yes, and you definitely know at a point 2y the velocity is going to be more compared to at a point 8y. You see, whatever this velocity, this is a velocity at a point 2y and this is velocity at a point 8y. Which velocity is more? Velocity at a point 2y is going to be more, yes or no? So this is 0.2 meters and here it is going to be 0.8 meters. So as a 0.2 meters, at a 0.2 meters, the velocity is going to be more. Now, just take the average, 0.6 plus 0.4 by 2. 0.6 plus 0.4, which is going to be 1, and the value is going to be 0.5 meters per second. Yes, and now, as is a triangle, what is the area of triangle? Area means half into base. What is base over here? 4 into height, 1. Yes or no? Half into base into height, so which is going to be 2 meters square. Now, area we know and average velocity we know. So, what is the distance? 2 into 0.5. Then the answer is going to be 1 meter cube per second. What is the units of discharge? The units of discharge is meter cube per second. So, what is the answer? The answer is going to be C, 1 meter cube per second. Say as simple as that. Now, everybody, if you observe, in this I mentioned the 2-point method of velocity measurement. Yes or no? When I mentioned the 2-point method of velocity, then I took at a depth of 0.2y and at a depth of 0.8y. If they would not mention all those things, then I will be taking the velocity only at a 0.6. Okay. So for better understanding of that, I will show you one more problem based upon this model. This is a 2 marks question in GATE 2012 and a simple problem only. Now, you see one more problem. I hope you can understand. See, just now we discussed this question. There I used directly the V average from the 2-point observations. Okay. Now, I'll show you one more question. So, this is a GATE 2018 set 2 question. Yes. Now, my dear, this is a very good question. Please have a look. In a 5-meter wide rectangular channel. So, what is the channel they have mentioned this time? Rectangle. So, the channel is going to be rectangle. This is a free water surface. Okay. So, what is the width of the channel? 5 meters. And the velocity distribution in the vertical direction. The velocity distribution, see they have given the velocity distribution. You know that the velocity distribution is going to be logarithmic up to maximum. Yes. So can I draw the velocity distribution please? Yes. This is a water surface. So this is the velocity distribution. And the velocity distribution is measured as, see this is a bed level. Yes. So what is the velocity distribution I mentioned you? 1.25 into y to the power of 1 by 6. Okay. And the distance y is measured from the channel bed. Keep that in your point. See whatever this distance is there, right? This distance y is measured from the bed level. You see, from the velocity distribution, at y is equals to 0. What is the meaning of y0? As I mentioned you, the depth is going to be measured from the bed level, y0. Yes or no? When y0, what is the velocity here?
Vx, the velocity is also going to be 0 here, right? So when you keep y0, u is also going to be 0. y0, u is also going to be 0. Okay. And as y increases, u also increases. Now, my dear students, they have mentioned the distance y is measured from the channel bed. Okay. If the flow depth is going to be, what is the flow depth? Y is equals to 2 meters. Y is equals to 2 meters. The discharge per unit width. So what is the discharge per unit width? They are asking. See, what is the difference between the previous question and this question? In the previous question, you observe, in the previous question, I gave you triangle, and for that triangle, I gave you the depth of flow and I gave you the top width. Yes or no? Yes. And in this question, I gave you triangle. Sorry, in the previous question, triangle. Now, in this question, it is going to be rectangle. Again, I mentioned you the width of 5 meters and depth is going to be 2 meters. If you know that, you can find out the area. Yes or no? Can't you find out the area of the rectangle? Yes, we can find out the area of rectangle. But I want to find out the discharge. Yes or no? And that too, discharge per unit width. So when I want to find out the discharge per unit width, now let's see. So discharge is nothing but, you know that, area into V average. Average velocity. Okay. So Q is nothing but B into Y. Why I am using BY? What is the area of rectangle? The area of rectangle is B, width into depth. For this cross section, right? What is the flow area? B into Y. So I want Q by B. What is Q by B? So what is Q by B? Y into V average. So I have already Y value. What is Y value? 2 meters. Now it's all about the V average. So what is V average? You need to find out the V average. See, in the previous question, now, I have mentioned you whatever the velocity at 0.2 meters, 0.2 y, so and 0.8 y, then you can use it directly. But in this question, did I mention you anything like that? No. Instead of that, I gave you the velocity distribution. So this is the velocity distribution. Now, did I ask you use any 2-point observation? No. Did I ask you 1-point observation? No. I told you clearly yesterday, when I don't mention anything, then you always go for 1-point observation. What is that? 1-point observation. So what is a 1-point observation? The 1-point observation is that velocity is going to be average at a depth of 0.6 y from the free water surface, or at a depth of 0.4 y from the bed level. 0.6 y from the free water surface, or 0.4 y from the bed level. So the difference between the previous question and this question, my dear students, you have to observe this one. In the previous, I mentioned you 2-point observation, so you can go for the 0.2 y and 0.8 y. But in this question, I did not mention anything. So it's better you go with the 1-point observation. And from the 1-point observation, 0.6 y from the water level, or 0.4 y from the bed. And you know that the depth is measured from channel bed or from water surface. The depth is measured from the channel bed. As the depth is measured from the channel bed, as the depth is measured from the channel bed, so you have to take the average velocity at a depth of 0.4 y. So now, what is average velocity, please? The average velocity means velocity at 0.6 y, velocity at 0.6 y from water level, or velocity at 0.4 y from bed level. So as the depth is measured from the bed level, you have to take velocity at 0.4 y. Okay. So as y is measured from bed level, as y is measured from the bed level. So now the V average is equals to V at a point 4y. So now, my dear, what is the velocity distribution, please? So the velocity distribution is going to be, if I want to make sure this has the average velocity, see, I'm giving you u, right? If I want to make sure this has a u average, then I have to provide this y as a how much? How much? At what depth? 0.45 times 0.4 times of y r1. So now, so u average is equals to 1.25 into, now what is the y value I have to substitute? What is the total y? 2 meters, right? And what is the 0.45, 0.4 times of y? So that is the depth at which we are going to measure the average velocity. Na? So 0.4 into 2 whole to the power of 1 by 6. So you please find it out. 0.4 into 2 whole to the power of 1 by 6 into 1.25. So if you solve, you will be ending this value as 1.204 meters per second. So once you get this value, then what is the discharge per unit width? The discharge per unit width is nothing but y. What is y value? 2 into V average 1.204. So which is going to be 2.408 meter cube per second per meter. So the point I have mentioned is, as y is measured from the bed level, you have to take the V average at a velocity at a depth of 0.4y. So if I apply the y value, what is the total depth? 2 meters, right? And 0.45 means 0.4 into 2, 0.8 meters. So if you substitute the y value as a 0.8, then this u becomes u average. I hope you understood the concept behind this. Please have a look. What is the use of finding discharge per unit width? This is not the use of. This is not the use. They are asking about find out the discharge per unit width. That's it. Okay. And some of the people say why you have given u average, because whatever the you see this, whatever the relation they mentioned is u. So that's the reason why I mentioned it as u average or v average. U or v both are same, Baba. U and v both represents the velocity only. So you don't need to worry about whether it's u average or v average. So as the equation, whatever the equation they mentioned is in terms of u, right? So if I substitute y as a 0.4y, then u becomes u average. Okay. So why can't we take the 0.65? We get the same answer? No, you don't get the same answer, my dear. See, I mentioned you y is measured from the bed level. Okay. You observe this figure clearly. You observe this figure clearly. See, when I take the y value from the bed level, where I am getting the average value? I am getting the average value at a depth of 0.4y from the bed level. And you see the clearly mentioned if the depth is measured from the channel bed. See, in the same question, if I would have mentioned that the equation, the depth is measured from the water surface. If I would have mentioned the depth is measured from the water surface, then you can use it as 0.61. Then you can use it as 0.61. Okay. So if I would have asked you from water level, if the depth is measured from the water level, I could take it as a V or velocity at 0.6y. And as I'm asking you from the bed level, you have to take it as a 0.4y, my dear. Okay. And some people are saying, sir, you're going too slow, please increase the speed. And some people are saying, sir, class is very fast. I don't know which one is true. Sir, if we had done this problem by 2-point observation, then also we'll get same answer. No, you don't get the same answer. If you have any doubt, you please have a look about that. Yeah. And if nothing is mentioned in this question, see, you observe this, you can see this function, and this function is clearly depicting that y0, u0, y increases, u increases, which means the measurement is from the bed level. If I would have changed this equation, then there is a possibility. So, and I want to go with this in other way. Just now have a look. Yeah. So these are the points that we have done based upon the field observations. Yes. From the field observations. Now, let's see one more way. Analytically, look, whatever the variation of this value is going to be small v, okay, you know that the discharge should remain constant, yes or no? Whatever the discharge, Q is nothing but A into V average is equals to A into V average is equals to, see, you can take this point now, you observe, this is the water level, this is the channel bed. Now, there is a velocity distribution again. You can take a small strip. You can take a small strip over here. So you can find out whatever this strip, the depth is going to be dy. And you can see the velocity over here or not. And you can find out the velocity variation from bottom to top. A into V average is nothing but whatever the velocity distribution, let's take it as Vx is equals to small v, integration over the total area, integration over the total area V into dA. So if you integrate this small element, right, you know this nothing but it must be having some width. Okay, this element must be having some width. So whatever the total discharge is nothing but total area into average velocity is equals to integral of a small portion of this area. Integral of a small portion of this area. So integral of V into dA, and I can write this one as integral of y V into this dA can be written as B into dy. B into dy. So what is the area? So what is the elemental area of this one? See, in perpendicular to this one, there is a width, right? This is what section? This is a longitudinal section. Yes or no? In the plan view, you can see the width. So integral of B into dy. And what is area? B into y is equals to V average. Now, what I am doing is simply I am equating the discharges. So whatever the total area into average velocity is equals to integral. See, you can do that average by taking the integration also. Now I can cancel down B and B. Then what is V average over here, please? The V average is nothing but integral of V into dy by total V. Integral of V into dy by total y. So if you can find out this, then that is going to be the V average. Okay. This is one way. This is analytical procedure. Just simply the total discharge is nothing but the elemental discharge. You just integrate over a total area. And what is this elemental area? B into this elemental depth is nothing but d. Okay. Now let's apply this one also to find out the velocity. This is average velocity, right? I'll go with one more way here. Analytically, the other procedure I am showing you here. analytically. So now, as you know, discharge is nothing but area into average velocity is nothing but integral of the depth, integral of the depth. So from, you see, whatever this variation is there or not, from 0 to y, from 0 to y, v into dA. What is dA? B into v into dy. And mind it, my dear, whatever the variation I have given you, see, this is the variation I have given you already. What is the variation? 1.25 into y to the power of 1 by 6. So that is the variation. Yes, that's a distribution function. So you need to integrate that from 0 to y, from 0 to y. And what I required is discharge per unit width or not? Yes or no? So now you see, can I write the discharge per unit width from here directly? You observe, what is this? You can take on this discharge width to the other side. Then he is going to be integral of 0 to y into u into dy. That's it. As simple as that. Now this time I am not finding the average velocity. You observe, you see the function. Discharge is nothing but area into velocity. The total area into, what is the total velocity I have to take? Should I have to take maximum velocity or average velocity? Average velocity is equals to, so you have to integrate from the 0 to the top water level y, u into b dy. So now you please keep out those values. What is the y value over here? Y value is going to be 2 meter. So now you integrate, please. Integrate of 0 to 2. Y is equals to 2. And what is the function I have mentioned? 1.25 y to the power of 1 by 6 into dy. So you can take out this 1.25 and the integral of y to the power of, okay, fine, anything power, x to the power of a is nothing but x to the power of a plus 1 by a plus 1, right? So integral of anything power, yes, x square x cube by 3. Similarly, you can find it out. Now, if you integrate that, so let's take out this 1.25 outside, y to the power of 1 by 6 plus 1 by 1 by 6 plus 1 and integral 0 to 2. So now you please find out those values. 1 by 6. So 1 by 6 plus 1 is equals to 7 by 6. Q by B is equals to 1.25 into y to the power of 7 by 6 by 7 by 6 integral 0 to 2. So you take this 7 by 6 to the other side, then Q by B is equals to 1.25 into 6 by 7 into, see, just 2 to the power of 7 by 6 minus 0. So which is going to be 2 to the power of 7 by 6 minus 0. Into 6 into 1.25 by 7. So which is going to be obviously 2.405 meter cube per second per meter. I hope you can solve this one, and once you solve, you will end up with the same answer. So you please have a look over here. I can write down this, the total average as a integral. See, what is the meaning of integral from 0 to y means the total whole body, right? Width is not constant, it is varying. Who said that? Width is constant only, my dear. See, the velocity is varying with respect to depth, not width. Keep that in your mind. See, you can use both analytical procedure. This is mathematical procedure. Analytical means mathematical procedure. And whatever, this is nothing but, see, this is from the observations. But at the end of the day, you're going to end up with the same answers or not. Either, I'm telling you, either you go analytically or you go but from the field observations, you can get the same answers. So you can approach in any manner. It's up to you. But already for the current meter, from the current meter, we know these observations, right? You tell me which one is simple. You tell me which one is simple. This one is simple, right? If you know the concept, you can directly apply the value. Else, if you're very good at mathematics, then fine. You can go with this equation. See, in this one, as the function they have given is simple function. This function is going to be simple function, right? As the function is simple, then it will be easy for you to integrate. But if I would have given something like that, so y to the power of some 7 by 8, or if I give you some complexity function in terms of ease, then it will be very difficult for you to integrate and go all those things. But as long as you're good at mathematics, then you can go for the integration. So it's up to you. You can follow any approach. Okay. So that's about the velocity distribution, and I hope you understood the differences between the 1-point observation, 2-point observation, and if you want to go for an analytical procedure, how to approach this question. Same way. Okay, so now corrections are required. Based upon this, see my dear, I want to ask you one question. Whatever the velocity distribution is going to be, is it a uniform variation? Is it a uniform velocity distribution? You tell me please. Is it a uniform variation? What is the meaning of uniform variation? From bottom to top, the velocity is going to be same. Does the velocity distribution is uniform? No. And as the velocity distribution is not uniform, whatever the average velocity we are going to take, so that velocity is not same as the actual velocity of the flow. Yes or no? See, I told you for the analysis purpose, we always take the average velocity. Yes or no? When you take the average velocity, then there must be some error. See, at a particular point, what is the velocity that represents v? But for the whole medium, you are going to take one velocity as average velocity. Do you think always the average velocity and the velocity at a particular point both are same? No. Definitely there must be some error. For example, while I want to find out the energy, you know, the basic fundamentals of fluid mechanics runs on 3 equations. Conservation of mass, which means how much flow of water is going inflow, outflow by means of discharge. Conservation of mass represented by continuity equation Q is equals to A1V1 is equals to A2V2. I hope you understand that. The first basic principle of fluid mechanics or fundamentals of fluid mechanics is conservation of mass by continuity principle. Second one is conservation of energy. Conservation of energy means a Bernoulli's principle. At any section, total energy remains same. Okay. Next, third one. So if you look over the third one, you see fundamentals equation of fluid mechanics. So conservation of mass, which represents a discharge, okay, A into V, and conservation of energy, which represents Bernoulli's principle. So what is the total head? P by rho g plus velocity head v square by 2g plus datum head. Next, conservation of momentum. So according to the conservation of momentum, the net force acting along the direction of flow, is equals to rate of change of momentum. See, what is momentum? If an object is going to be moving with some velocity, what is the momentum? Mass of that body into velocity. Yes, mass into velocity. So the momentum means mass into velocity. Why I'm saying all these things again over here is, my dear student, if you observe carefully, whatever the velocity we have to take is nothing but average velocity or not. This is going to be the average velocity. That's going to be the average velocity. Now, just now I told you, this is the variation of the velocity. But what we do take is, for analysis, I am going to take it as an average velocity. Okay, I'm taking an average velocity. So when I substitute these values over the conservation of energy or conservation of momentum, in the conservation of energy, this portion is nothing but the kinetic energy, or this portion is nothing but the kinetic energy, which means that kinetic energy, when you apply V average instead of normal V, then there must be some error. Similarly, in the case of conservation of momentum, in V average, if I substitute the velocity, then I'll get some error, and that error we are going to correct by means of some correction factors. I hope you understood. This is the actual velocity distribution, but for the analysis, are we taking the total distribution? No, we are taking the average velocity. So if you substitute that average velocity in kinetic energy, then the value we attain is not the actual. We need to apply some correction. Similarly, for the momentum also, we need to apply some correction. Now, what are those corrections? Correction factors. Number 1, kinetic energy correction factor, represented with alpha. So represented with alpha. So what is alpha here is, whatever the variation, the distribution has some variation or not. Yes. Now again, for the same element, you integrate integral of V cube into dA by V average cube into A. Integral of V cube into dA by V average cube into dA. I'm sorry, suddenly the video has been stopped. Okay, yeah. So kinetic energy factor, the integral of V cube. See, what is this V? The V is nothing but, see, the variation small v, and is going to be average velocity. Then kinetic energy is equals to alpha into V average square by 2g. What is kinetic energy per unit weight? V square by 2g, kinetic head, right? Then the kinetic head per unit weight, or kinetic head, I can write this one as a kinetic head. So kinetic or velocity head. You can call the kinetic head or velocity head. So alpha into V square by 2g. V square, there the V is going to be average velocity. See, you don't need to worry about the questions appearing from this, but you need to know what is the equation, how does the equation looks. And this is a kinetic energy correction factor. Similarly, There is second one. Momentum correction factor. Momentum correction factor represented with a beta. What is this beta, sir? See, this is integral of V cube. Now integral of V square into dA by V average square into A. Integral of V square into dA by V average square into A. So this is a momentum correction factor and this is a kinetic correction factor. And in a previous year, see, there was one instance where they asked which one of the following represents the momentum correction factor. So that's the reason why I am providing you both formulas, what is alpha and what is beta. And coming to this alpha and beta, now note point. Generally, alpha is greater than beta is greater than 1. Alpha, see, alpha and beta both are greater than 1, and which value is going to be more than, which value is going to be more out of these two? Alpha. Alpha is more than beta. Alpha is going to be more than beta. And keep that in your mind. If you observe, my dear students, if the velocity distribution is going to be uniform, if the velocity distribution, let's say this is the velocity distribution, please listen. Let's say this is the velocity distribution. What is the meaning of this velocity distribution? This is going to be uniform velocity distribution or not, which means you take at any point, the average velocity is going to be same. Yes or no? At any point, the average velocity is going to be same as that velocity. If I say at this point V, everywhere the velocity is going to be V. Then do I apply any correction? No. For uniform velocity distributions, if the velocity distribution is going to be uniform, you don't need to apply any correction. But the more the non-uniformity in the velocity distribution, the more the non-uniformity in the velocity distribution, the more the alpha values. So for uniform velocity distribution, which we are not going to see in the case of the channels. So alpha is equals to beta is equals to 1. And in open channel flow, generally the alpha value is going to be 1.10 and beta is equals to at a range of 1.05. So if the velocity distribution is going to be uniform, then alpha and beta both are is equals to 1. But see, for this is a for non-uniform velocity distribution, you are going to apply this alpha and beta in the case of the pipe flow also. In the case of the pipe flow also, you need to apply the correction factors. But what I am discussing is open channel flow, right? In the case of the open channel flow, the velocity distribution is not uniform. This velocity distribution is logarithmic. So the alpha and the beta will not be same and they are not going to be equals to 1. Alpha greater than beta greater than 1. So what is alpha value? 1.10. And what is beta value? 1.05. And with this, I have concluded all the things regarding to the velocity distribution. I hope you have been gone through the notes yesterday I have provided. So velocity distribution, how does the velocity looks like, and how the components are going to be taken, and how the velocity is not going to be maximum at the surface. What are the reasons behind that, and what happens if there is an aspect ratio, and then we discussed about the average velocities, and then we discussed about the analytical procedure. Now I am discussing about the correction factors also. So that's all with the introduction. Now so far what I have mentioned is introduction only. Still I did not discuss the entire topics of the open channel flow, whatever the things that you require. So now at this point of time I'll ask you some questions. Alpha and beta cannot be 0. Okay, fine. So that's about these correction factors. Now, with all the things so far we have mentioned, I can give you some quick review for the open channel flow. What is open channel flow? Open channel flow, the flow with a free water surface is known as open channel flow. And is it pressure flow or non-pressure flow? What is the differences? So open channel flow is a non-pressure flow, whereas a pipe flow is a pressure flow. Okay. Second point. In the case of open channel flow, always a flow occurs from high datum to low datum. Yes or no? But in pipe flow, flow can occur from a high datum to low datum or low datum to high datum due to presence of pressure. Point number 3. In the case of the open channel flow, which force is dominant? Gravity force is going to be dominant. I explained you that clearly yesterday. Which force is going to be dominant in the case of the open channel flow? So in open channel flow, the force, which force is going to be dominant? Gravity force is going to be dominant. Whereas in the case of the pipe flow, which force is dominant? Viscous force is dominant. So that is the reason why in open channel flow, I use a Froude's number. In pipe flow, I am going to use whatever the subject that you are going to see. In pipe flow, you are going to use the Reynolds number, not the Froude's number. So open channel flow is also known as a gravitational flow, whereas a pipe flow is a viscous flow. Pipe flow is going to be the viscous flow. And in the case of the open channel flow, always hydraulic gradient line coincides with the free water surface. Whereas in the case of the pipe flow, the hydraulic gradient line will not coincide with the free water surface. And then coming to the velocity distributions, so this is the velocity distribution. And as a lot of people has not came across the pipe flow, I'm not going to discuss about the velocity distribution of pipe flow. So that's about the basic and introduction regarding to the open channel flow. Now, let's see what are the remaining things, how conceptually we go. And in the starting days, yesterday in starting, I showed you some practical applications, right? So I hope you can see these practical applications. Where do you see the open channel flow, please? So we see the open channel flow in natural rivers and in man-made, means we construct canals for navigating the water or transmitting the water from supply or from source to place of need, such as for irrigation and water supply. Yes or no? So wherever there is a canals, whatever the flow is going to be the open channel flow. Now I need to look over what are the different type of canals or channels we are going to see, and what are the cross section shapes of those channels. Now it's yours. Okay. So now here comes types of channels. Types of channels. So number 1, prismatic channel. Prismatic channels. So what is meant by prismatic channel? Okay. Now you see, let me take one section, a rectangular section. So a section. If I say this is a rectangular section, so the shape. So definitely this section has some shape, and what is the shape of this section? So this is a rectangular section, and it must be having some sizes. What is the sizes? So for a given section, there is size, right? What is the size? B. So width is going to be the B, and the depth of flow is going to be Y. And in the longitudinal section, this is cross section and this is longitudinal section. Definitely this soil, sorry, definitely this bed has some slope. Yes or no? So whatever, this is nothing but theta, which is going to be the bed slope. Yes. Now, for any channel you take, it has some shape. Yes or no? It has some shape. So for the given, the shape is going to be rectangle, and it has some size. What is that size? Width. Yes. And it has some bed slope. Now, when do we call it as a prismatic channel, sir? When do we call it as a prismatic channel? If for a given channel section, if the shape, size and the bed slope, if the shape, size and bed slope remain constant, means if the shape and the size and the slopes are not going to be changes, then we call it as prismatic channels. Then we call it as a prismatic channels. Sir, where do we observe this one, sir? All man-made canals. See, when we construct, we always provide some lining or not. Let's see this figure. You observe this figure. I hope you can observe. See, whatever this is nothing but lining or not. Whatever this is nothing but a concrete lining. Yes or no? If I provide the concrete lining, see that this is going to be the trapezoidal section. This is a trapezoidal section, and you are providing a concrete lining on the sides and at the base. Now, you tell me, when the water is going to be flows over here, due to the velocity of the flow, the sides may get eroded. Yes or no? It is going to be cause scouring and silting. But when I provide a lining, do you think any scouring and silting is going to be exist? When we construct, means when I construct man-made canals, for the man-made canals, we are going to provide the lining, right? When you provide the lining, then you see along the stretch, what is the shape? If I take here also, the shape is going to be trapezoidal. If I take here also, the shape is going to be trapezoidal. And down the line, if you go 1 kilometer or 10 kilometers away, the shape is going to be trapezoidal. And you can observe the width, the base width of the trapezoidal section here and here, both are same, right? Yes or no? So whenever you see, you can observe whenever the shape, sizes, and it must be having some bed slope. If all those are remains constant, then we are going to call it as a prismatic channel. So in simple words, what is meant by prismatic channel? Yeah. Prismatic channel means if shape, comma, size and longitudinal bed slope. The meaning of longitudinal bed slope means along the flow, whatever the slope. Longitudinal bed slope remain constant over a long stretch for a given channel. Then we call it as a prismatic channel. So what is meant by prismatic channel? If the shape, size and the slope. And I hope if you have completed the strength of materials, you may come across the prismatic bars. If the cross section is going to be constant, then we can call it as a prismatic. Yes. So now the cross section has some shape and some size. They're going to be constant. Then we call it as a prismatic channels. So what is the example for this one, sir? All man-made canals. All man-made canals. Now, so now this is not the end. Now let's go back to the other again. Okay. So again, you see, when the flow is going to be happen, see this concrete lining must be having some roughness. Yes or no? So it must be having some roughness. I don't know what is that roughness, but it must be having some roughness. Yes or no? So there must be some roughness for this line. Okay. Now, my dear students, If I take a natural channel, in the case of the natural channel, let's take a river. This is a canal. If I take a river, in the case of the river, are you going to provide any lining? Have you created it? No. So that's a natural channels. In the case of natural channels, due to silting and scouring, the shape of the cross section is going to be continuously changes. Now, if a shape changes, the sizes are going to be changed. The slope is also going to be changes, and roughness is also going to be changes. Now, based upon the boundary. So now, what is this boundary here? The boundary. See, you can provide a concrete lining, or you can provide a wood lining, or you can provide a glass lining, or you can go for a geomembranes and geotextiles also. So whatever the lining, if you provide some lining, then the shape, size, slope remains constant. And now based upon the boundary, now based on boundary, if it is non-deformable, what is the meaning of non-deformable or erodible? Or erodible, which means roughness remain same. Roughness remains same. So based on the boundary, if it is non-deformable means the shape or cross section is not going to be changes, and roughness is also going to be same. So when the roughness is going to be same, then we call it as a rigid canals. What do we call? Rigid canals. Then we can call it as a rigid boundary canals. Now, my dear students, can I say if roughness is going to be same, the rigid boundary canal is nothing but prismatic channel. Okay. For the rigid boundary canal, it must be prismatic, which means the shape, size, slope must be constant. Arey sir, you are saying everything is constant, then what is the variable over here? You see, the depth of a flow is going to be the variable. My dear, you see, whenever you observe this condition, this channel is going to be same. This channel is going to be same. But due to seasonal variations, if during a rainy season, do you think the flow of water is going to be same over here? No. In the case of the rainy season, for an irrigation purpose, my dear students, you tell me, in the case of the rainy season, you don't need to supply more water for the crops, do you? No. Why? Because due to rainfall, already some amount of the water will be appreciated to the crops. So you don't need to supply more water. But during summer season, due to inadequate rainfalls, you need to supply more water in the canal. So now my question for you is, do you think if I give you this canal, this is a canal, so do you think always the flow rate passing through the canal is going to be same? No. Always the depth of flow is going to be same? No. So which is the only variable here? The depth of flow. The depth of flow is going to be continuously varies with respect to time. So now, if you can understand this, then what is the only variable that we are going to see here is known as a depth of flow, and we call that as a degree of freedom. What do we call? Degree of freedom. So now, how many things are there I am discussing? You observe here, 5 things I am discussing over here, and now observe clearly: depth, shape, size, slope. Okay, and if a size, shape, or slope remains constant, then roughness is also going to be constant. So keep the roughness aside. So now total how many parameters are there for? Depth, size, shape, slope. So in the case of the prismatic channel, shape, size, slope remains constant. What is the only variable? Depth of flow. So now here, degree of freedom, DOF, is equals to only 1. So the only variable here, the degree of freedom means variable, is going to be depth of flow. With this, I want to conclude one point is throughout the open channel flow from now onwards, whatever the concepts we are going to discuss, we deal with the rigid boundary canals only. We deal with rigid boundary canals only. Sir, if it is going to be deformable, sir, then what do we say, sir? We call it as a mobile boundary canals. We call it as mobile boundary canals, and that I'll discuss. So what are the examples here is all man-made lined canals, all man-made lined canals and non-deformable unlined canals. See, keep that in your mind. I'm not giving as unlined canal. Unlined means no lining, but it is going to be non-deformable. In the case of the rocky strata, see, if you are going to dig a canal in a rocky strata, as it is a rock, do you think the water can erode a rock? No. So non-deformable unlined canals and all man-made lined canals, all man-made lined canals are going to become as a prismatic channels. And if I say prismatic channel, there is a possibility of rigid boundary canals. So throughout the open channel flow, we deal with the rigid boundary canals because the degree of freedom, what is the degree of freedom over here? Only one, because I'm not going to define any other things. So from here onwards, our hero is going to be depth of flow only. The only variable we discuss is depth of flow. With the depth of flow only, I'm going to reveal all the type of flows and how to analyze the open channel flow. Remember, it's non-deformable or erodible means non-erodible. Okay. Should I have to write the whole? Fine. Or non-erodible. Okay. That slash represents non-deformable or non-erodible. Fine. So now let's see. Then if this is the case, then you can say the second one, non-prismatic channels. What is a non-prismatic channel? So simply if shape, comma, size and slope changes for a given channel. For a given channel, if the shape, size and slope is going to be changes, then we can call it as a non-prismatic channels. My dear, if shape, size, slope changes, then the roughness is also going to be changes. If all the above changes, then roughness of boundary means also changes. Makes it deformable. When I say deformable, then what type of canals? So those are mobile boundary canals. Mobile boundary canals. So now you tell me, in the case of the non-prismatic channels, how many variables are there? Shape changes, size changes, slope changes, and the depth of flow is also going to be changed or not? Yes, obviously. So if shape, size, slope constant, the only variable is depth of flow, degree of freedom is 1. But here in the case of the non-prismatic channels, shape changes, size changes, slope changes, depth is also going to be changes. So how many degree of freedom? Degree of freedom DOF is equals to 4. What are those? Size, shape, slope, and depth of flow. So what is the example for this? Natural channels and man-made unlined canals. So now you want to tell me, you are an engineer, right? For the analysis, always keep that one point. We always do the ideal analysis, which means we always reduce the complexity. Now, should I go for the degree of freedom 4 or should I go for the degree of freedom 1? You tell me. Degree of freedom 1, because as much variables you reduce, that much of complexity you can reduce. So in the case of the total open channel flow analysis, we assume the boundary as a rigid boundary canals only. So the final note point here is note point in OCF analysis. Assume the channel boundary as rigid boundary canals. If I say rigid boundary canals, then definitely it is going to be prismatic. If I say rigid boundary, then definitely it is going to be prismatic. Okay. So I hope you understood this. What are the different type of channels? Prismatic channels and non-prismatic channels. Okay, fine. Have a look about that. Okay. I hope you can understand this now. So that's all about the type of channels. Now let's see. Shapes of cross sections. So now I hope you understood what analysis we are going to do for the rigid boundary canals. What is the meaning of rigid boundary canal? All man-made linear canals are not. So that's we are going to call it as rigid boundary canals. So now, what are the different shapes of the cross sections? What are the different shapes of the cross sections? Number 1, rectangle. So from the starting onwards, I was taking the rectangle. So this is a rectangular channel, and this is a water level, and you know this is going to be the depth of flow section Y, and this is going to be the width B. Sir, when do you prefer the rectangular section, sir? We prefer the rectangular section in the case of the rocky strata. In the case of the rocky strata. Preferred in rocky or boulder strata. So number 1, rectangle. Number 2, triangle. So there is a triangle, and this is the free water surface, and you know this is the depth of flow. Yes. So in the case of the triangle, you can see the sides. If you observe the sides must be having some slope or not. Let's take that slope as a 1 vertical to m horizontal. 1 vertical to m horizontal, where m is a side slope. Okay, where m is side slope. So second one is going to be triangle. Sir, where do you see the triangular channels, sir? So we observe the triangular channels, especially in the laboratories only. I hope you may came across the triangular notch. triangular notch, rectangular notch, notches and VF, right? So, and for the ESC people, we are going to discuss about those notches, but for GATE, it is not your syllabus. So, but anyways, so that's triangular channel, generally we see to measure the flow rate, to measure the flow rate. The purpose of that triangular channels is to measure flow rate. Flow rate means discharge. So for the measurement of the flow, we use generally triangular notch. That's the best suitable notch. So that's a triangular channel. And rectangle is whenever there is a rocky strata or boulder strata, we go for the rectangle. Now there comes trapezoidal. A lot of people have a doubt why we take the trapezoidal mostly. And I have cleared the doubt of those people who have attended for the geotech. I told you there, generally, now whether you have attended the geotech or not, generally soil mass cannot stand vertical. Soil mass cannot stand vertical. So in the case of the soil mass, when you do the excavation, you cannot dig the excavation vertically. If you dig the excavation vertically, you need to provide a support. You need to provide a support. So as a soil mass is a weak in vertical, it cannot stand vertical. It cannot stand vertical. So my dear student, here, this is a trapezoidal channel. This is the trapezoidal channel. So whatever here it is going to be the water level, and definitely this trapezoidal has some width, base width, and some side slope, one vertical to m horizontal, and some depth of flow y. So where do we prefer this trapezoidal channel, sir? We prefer this trapezoidal channel in soils, or preferred in soils. And this side slope is not going to be constant. It is going to be varies for different type of soil masses. See, if the strata is going to be rocky strata, you can do the vertical excavation. But if the strata is going to be soil, then you have to go for the trapezoidal. So that's the reason why. See, if you go over here now, so in this case, this might be the rocky strata or a boulder strata. So you can observe. I hope you can observe whatever this channel is going to be the rectangular channel, right? Yes. Whatever this channel is going to be the rectangular channel. Okay. But if you observe here, whatever this channel is going to be the trapezoidal channel, and next to this you can see the crops over here. So this strata here is going to be completely a soil mass. In the case of the soil, you cannot go for the vertical sections. You have to go for the trapezoidal. Okay. And this is also going to be one of the channel where you can provide some side slope, but this is an unlined canal. Can you see any lining over here? No, this is unlined canals. This is going to be the unlined canal. Now, yeah. So in the case of the trapezoidal, we preferred, so for the soil masses, we go for the trapezoidal channel, and this side slope depends upon the denseness of the soil mass. Side slope depends on denseness of soil. So number one, rectangle, triangle, and trapezoidal, and last one, circle or semicircular. See, you can go for the circle, but when you go for the circle, now my dear students, is it a closed section or open section? Closed section, yes or no? So now let me take a So this is a circular section, right? But in the case of the circular section, are you going to allow it full or partial? Partial. If you allow it full, then it is no more open channel flow. So In the case of the circular section, if you allow it partially, then this is going to be the open channel flow. And the best example is going to be sewers. I hope you know the sewerage system. Sewer is a conduit where you are going to transmit the dry weather flow and wet weather flow partially. Yes, and else you can go for the semicircle. Yes. So this is a semicircle, and generally we use this one in the case of the culverts. So example, so we prefer the circular open channel flow pipes for the sewers, and other one is going to be the culverts. So these are the various shapes of the cross sections, but generally we prefer trapezoidal. Why? Now let's see. You observe, for everything, for every cross section, there must be some weighted perimeter. Yes or no? What is mean by perimeter, sir? What is mean by perimeter? The length of the solid boundary is going to be the perimeter. Okay, sir. In the case of clays, we can excavate, but everywhere you are not going to see the clays, right? And in the case of the clays, you can excavate up to critical depth only. So every time you go there and you check the soil mass, see, for the construction purpose that is necessary, but for the excavation purpose, we try to go for the trapezoidal. Why? Now I'm going to tell you why. Because, so what is the reason behind why we prefer trapezoidal sections most? Number one, stability point of view. Number one, stability point of view. Now, number two, cost point of view. You just have a look what I'm going to say here. Listen, for all the channels, you can see the cross-section area. What is the cross-section area of the rectangle? B into Y. So the triangle, half into base into height. Trapezoidal you can find out, and the semicircular also you are going to be find out. Okay. Now, for all the sections, for same cross-section area, let's assume the cross-section area of all the cross-sections are same. The flow area, whatever the flow area is there, right? Whatever the flow area or cross-section area. So for same cross-section or flow area, out of all the section, everything has some weighted perimeter. What is the meaning of weighted perimeter? The meaning of weighted perimeter is the length of a solid boundary which is in contact with the water. What is the length of solid boundary which is in contact with the water? From here to here, the center is going to be the length or not? Yes. So, yeah. What is the length of the solid boundary which is in contact with the water? The sides Y and base B, and again is going to be Y. What is mean by wetted perimeter? So the wetted perimeter means the length of the solid boundary which is in contact with the water. The length of the solid boundary which is in contact with the water. Whatever the dashed line I am representing, that length. The length of the solid boundary which is in contact with the water. That is known as a wetted perimeter. Now, for same cross-section area, out of all the sections, whichever is going to be the least wetted perimeter. See here, the cost depends upon the lining. Whatever dashed line I am representing, that dashed line means lining. I told you clearly in the open channel flow, what type of sections we are going to take? Rigid boundary canals. The meaning of rigid boundary is lined canal. Yes or no? So when I provide the lining, in the case of canals, 50% of the cost is about the lining only. Okay. So now, if I say I want to make sure economical, then I have to reduce the material for the lining. Yes or no? So when I can reduce the lining, if the weighted perimeter is going to be less, you see, if the weighted perimeter is going to be less, then the cost of lining is also going to be less. Am I correct or not? Where we are going to provide the lining, you see. Yeah. You can observe, see, whatever this is nothing but the boundary, right? And this is nothing but the weighted perimeter, the total length, B plus the side slopes. So you can provide the lining over here, lining at the base and lining at the sides. As when the weighted perimeter is going to be less, then the lining required is going to be less. When the lining required is less, then the cost of lining is also going to be less. When cost is less, then I can say it as economical. So out of all the sections, if I want to make sure the economical section, the weighted perimeter is going to be less. So now I can write a point over here as note. Out of all sections for same cross section area, for same cross section area. So the cross section area is going to be same. Whichever yields minimum weighted perimeter, whichever is yields minimum weighted perimeter, which means cost of lining is less. Whichever yields minimum weighted perimeter is known as economical section. Economical section. So for same cross section area, whichever has a minimum weighted perimeter, that is going to be the economical section. So what is meant by weighted perimeter, sir? Weighted perimeter means length of solid boundary which is in contact with water. So the length of the solid boundary which is in contact with the water, we call it as a weighted perimeter. So now, sir, you are saying for same cross section area, then which one has a minimum weighted perimeter, which one has a more, means a larger weighted perimeter? Now, order of weighted perimeter. What is the order of the weighted perimeter? Here is, you see, the order of the weighted perimeter is out of all the sections, semicircular section has least weighted perimeter, then trapezoidal section, then trapezoidal section, then rectangle is equals to triangle. Rectangle is equals to triangle, which means, you see, out of all the sections, the weighted perimeter is going to be least in the case of whom? Semicircle. So the semicircular section has a least weighted perimeter than the trapezoidal, than the rectangle. And for same cross section area, my dear, for same cross section area, the triangle and the rectangle yields the same weighted perimeter. Sir, how, sir? That we will see in the later sections. So those in the case of the channel geometry. But as of now, you please remember, because I am going to show that proof in later. Don't worry about that. I'll show you the proof. By taking the magnitudes, I'll show you the proof. Alright, don't you have some patience levels? Why don't we use semicircular sections? Why we use trapezoidal? I did not complete it here. Okay, now very good question. So now, sir, you are saying that trapezoidal section is the most used section, but you are saying here as a weighted perimeter is going to be very less for the semicircle. If the weighted perimeter is less, then economical section is going to be the semicircle. Nah? Then why we use trapezoidal most? Because though semicircular section is economical in paper, it is very difficult in design. Do you think the channels that we are going to, or canals we are going to construct, they are going to be 1 kilometer? No. The canals that we are going to construct are going to be runs over a longer stretch, kilometers and kilometers of range. So as many kilometers it has to be constructed in order to provide such a curvature. In order to provide such a curvature for the semicircle, it is a very difficult. Though it is economical, but it is very difficult in the design aspect. In the design aspect. So semicircular is section is economical in paper, but in the case of the design, it has its difficulties. Then which one we have to prefer? Then which one we have to prefer? As the design conditions of the semicircle is going to be highly unsuitable or difficult, then I can go for the next one is going to be the trapezoidal. Sir, if I go for the rectangle, sir, if in the case of the rectangle, the design is going to be very simple, but its vector perimeter is going to be more. So it's not going to be economical. So in semicircle, economical, but considering the design point of view, difficult. Rectangle, design is simple, but not economical. So which one we are going to prefer most? Trapezoidal. Though semicircle section is economical, due to its difficulty in design, trapezoidal section is commonly preferred. Okay, so that's about the type of cross sections. Yeah, type of channels. Out of these channels, I told you which type of canals we are going to take. Rigid boundary. If I take rigid boundary, that's going to be prismatic only, and then shapes of the cross sections where we are going to use, and the conclusion points for those. All these things are previous ESC questions. So once we start the previous ESC, there you can understand all these questions. All these options are much better. So now, okay, fine. So if you have any doubts, you can have, but already it's 8:35. So you have a small break, 15 minutes break. Have a break of 15 minutes. So we'll start or we'll resume our session at 8:50. Have a small break.
Okay. Now, so let's get back to the session. Yes. So I hope you people are doing good regarding to your preparation. And one more thing I want to know here is I want to create a poll regarding to as some of the students were college goers and possibly almost all the colleges has been started the online classes. So some of the people might be having their online classes at 9 o'clock or 10 o'clock. So um, from the management side, they want to know at what time it is feasible for you people, whether it is going to be 7 to 10 or 6:30 to 9:30. So I'm going to create that poll. I have not created a poll so far, but let me see that. So I think I have had that. And I don't know how this poll works also. Let's see that. And meanwhile, you people, you see that, and let's start. Some of the students are asking, sir, how do I answer the poll? Reba, this is the first time I created a poll. I don't know how to create a poll also, so don't ask me how to answer that also. Just have a look about some screen. On the top of your screen, there might be a pop-up. So regarding to that. Yeah. Now, come to our session. Okay, I need it. I didn't add it. No. Yes, it's already there. So it's already there. I think people have made that. You please have a look, and whenever there is a possibility, I'll look at that and I'll see. Okay, fine. Yeah. So total. I think it is going to be a tiebreaker because it's like 55-60%, something like that. Let's see. Let's say at the end. Okay, fine. So instead of this one, yeah. Now, so my dear, we have been discussed about how the flow is going to happen in an open channel, and on what basis the flow is going to be start, and what are the different type of channel cross sections and different type of the channels. Now, look, you know that in a given channel, let's take whatever the channel we have. In a given channel, throughout its lifetime, the flow rate is not going to be constant. Yes or no?
So sometimes due to seasonal variations or due to supply and demand fluctuations, the flow rate passing through the canals, either for irrigation or water supply, it gets varies. So now, in order to study that flow characteristics, we need to classify the flow, whether the passing, whatever the flow passing over here, whether the flow is going to be uniform flow or whether it is going to be non-uniform flow, whether it is a steady flow or whether it is an unsteady flow, whether it is a varied flow or whether it is going to be not varied flow. So you need to classify the flows. Yes. For the classification of the flow, now question number 1 for you. For example, if I send some 10 meter cube per second of discharge for some 10 meter cube per second of flow rate in a rectangle and a triangle. So two channels are there. I am sending the same discharge. Now, do you think the flow will be same in both the channels? No. For example, so I'll go with the pipes, and based upon that you can understand much more better. You take up two pipes, two circular pipes. One is made up of PVC and the other one is made up of concrete pipe. Okay, concrete pipe and a PVC pipe. Now, let's say I'm going to send the same discharge in both the pipes, and let's assume the pipe or two pipes has the same diameter. Two pipes has the same diameter, but one is made up of PVC, other is made up of concrete. And if I allow the same flow, do you think the flow parameters are going to be same there? Do you think the velocity of flow is same in both the pipes? No, because one is made up of PVC, other is made up of who? Concrete. So two different materials has a different roughness and two different material has a different friction. So different velocity and different flow parameters, and the flow can be either laminar or turbulent. So similarly, whatever the flow you pass, and when you allow that flow, the behavior of that flow depends upon shape of the cross section, sizes of the cross section, longitudinal bed slope of the cross section, and the roughness of the cross section. So on all these parameters, you're going to look over the flow behavior. So for that, we look over, just like I said, shape and sizes, right? So we need to look over how the geometry of a channel looks like. Once we know the channel geometry, then we are going to classify the type of flow. Okay, fine. Okay, fine. So now let's come to that. The next heading, channel geometry. Okay. So channel geometry means what are the various cross-sectional details that we need to know to classify the flow. Now, let's take an irregular channel like this. It's a regular or irregular. Regular means lined, irregular means unlined. So it's an irregular channel, and you know this is a free water surface. Now, what are the various parameters for a given channel geometry? Observe carefully. Number 1, the depth of flow section represented with y, depth of flow section, and whatever the width of the water surface, this is going to be the top width. You see, you can observe in these figures. So whatever this is nothing but the top width, and here also you can see whatever this is nothing but the top width, which means width of the water flow. And now this is a top width T, where T is width, and apart from that, you can observe from here to here, whatever this is nothing but the length of the solid boundary which is in contact with the water. Yes or no? So just now I mentioned before the break, what is the length of the solid boundary that is in contact with the water is nothing but weighted perimeter, right? So now this is known as a P, where P is weighted perimeter. P is going to be the weighted perimeter. And once you know the cross-section shape, can't you find out the area? If I say this is going to be rectangle, then you can find out the area where A is nothing but cross-section area or flow area. Cross-section area or flow area. Okay. So these are the channel geometry details we require: the depth of flow, top width, weighted perimeter, and cross-section area. Now, from this, what we are going to get is two parameters, two hydraulic parameters. So those hydraulic parameters are very, very important. Those hydraulic parameters are: number one, hydraulic depth, represented with D. Hydraulic depth represented with D. So what is meant by this hydraulic depth? Hydraulic depth means for a given cross section, whatever the flow area per unit top width, whatever the flow area. So for a given cross section, if I say this one, based upon the flow rate, you are going to set the flow area. The depth is going to be changes or not? Yes or no? So for a given cross section, whatever the flow area per unit top width is nothing but the hydraulic depth. So D is equals to flow or cross section area A by T. Flow or cross section area A by, what is the top width? The top width is going to be represented with T. Okay, so that's about the hydraulic depth. The hydraulic depth D is equals to A by T. Sir, what is the significance of the hydraulic depth? I'll tell you later. What is the significance of the hydraulic depth. But as of now, what is the hydraulic depth? D is equals to A by T, cross-sectional flow area per unit top width. Now, second one is equals to hydraulic radius or hydraulic mean depth. Hydraulic radius or hydraulic mean depth. So it's up to you, but in our terminologies, generally we call it as R, hydraulic radius only. So in some textbooks and in some examinations, they may try to confuse you by giving hydraulic mean depth. Hydraulic mean depth is different, hydraulic depth is different. So the hydraulic mean depth is also known as a hydraulic radius, where hydraulic radius is equals to whatever the flow area per unit weighted perimeter. See, if I take per unit top width, that is going to be hydraulic depth. And for unit weighted perimeter, that is going to be the hydraulic radius. Cross-section area per unit hydraulic. Cross-section area per unit weighted perimeter gives hydraulic radius. So based upon these two, we are going to classify the flow. And how these are going to be helpful, sir? Let's start with one by one channel. How many channels we have? 4 different type of channels are there or not? So we have 4 different type of channels, and we try to apply the hydraulic radius and hydraulic depth for all the flow channels. Then from there, we can find out what is the purpose of this. Okay. So now let's see. Should college going batches from Hyderabad attend hydrology class at 10:30 AM? Please confirm it is possible. No, for the college goers, I already told you yesterday. Again, you will be having at 10:30, right? So at 10:30, you're having a hydrology class, but that is not for the college goers. That is for the regular batch people. So for the college goers, you don't need to attend the hydrology class. That will be, you can attend that again later. That will be conducted again later. Okay, so don't worry about that. Now we got the poll details out of the total 60% of the people are opting for 7 to 10. 40% of the people are opting from 6:30 to 9 a.m. So majority, as we live in democratic society, so we go for the majority. The class timings will be from 7 to 10. Okay, fine. So now let's apply these channel geometry details for one by one. Number one, rectangle. If you discuss about the rectangle, in the case of the rectangle, so this is the water level. Now here it is going to be the depth of flow y and width of the channel as b. Now tell me one by one, what is the top width, what is the wetted perimeter, what is the cross section area. So depth is nothing but y. First of all, say I need to find out whom, hydraulic depth and hydraulic radius. For that I required area, top width and wetted perimeter. So now what is top width over here? See, the top width is nothing but this portion or not. The top width is nothing but the width of the rectangular section. So the top width of the flow in the case of rectangle is nothing but b, right? And what about the wetted perimeter? See, what is meant by wetted perimeter? Whatever the length of the solid boundary, here b and this side y and this side is also going to be y. So y plus b plus y, y plus b plus y. So I can write as a b plus 2y. I can write as a b plus 2y. So what is the wetted perimeter? Wetted perimeter is nothing but b plus 2y. And what about the cross section area? Cross section area is equals to by. So the cross section area of rectangle is going to be by. Okay. Now, my dear fellows, yeah. So once we know the cross section area, wetted perimeter and top width, then we need to find out the hydraulic depth and the hydraulic radius. So how to find out the hydraulic depth? What is hydraulic depth? D is equals to A by T and D by by B. BB gets cancelled, then D is equals to Y. Now, my dear students, what is the significance of this D? What is meant by D? Sir, you are saying that hydraulic depth and you just have given the formula, but what is the actual meaning of D, sir? The actual meaning of D is the average depth of the flow section. The average depth of the flow section whose sides are not converging at top. Whose sides are not converging at top, or whose sides are diverging at top. So you see here, what is the meaning of hydraulic depth? Hydraulic depth means area by top width, right? See, the top width T is going to be located if the sides are not going to be converges. If the sides are going to be diverges, see, the sides are going to be diverges, right? Are they going to be converging? No, they are going to be diverging. So then only the top width is going to be present. If you see the circular section, in the case of the circular section, the sides are going to be converges. When the sides are going to be converges, then the top width you cannot find it out. Yes, sir. So what is mean by hydraulic depth is the average depth of the flow section. What is that? The average depth of the flow section. This is the flow section rectangle. The average depth of the flow section whose sides are going to be diverges are not converging at the top. Okay. So if you observe, see here the depth of flow. If I take at this section, what is the depth of flow? Y. At a center also depth of flow y. Anywhere the depth of flow y. Then what is the average depth of this section? The average depth is also going to be y or not. Switch. In the case of rectangle, wherever you take, the depth of flow is going to be y. It's a uniform, na? The depth is uniform. Whereas the depth is uniform, then the average depth is also going to be same. So D is equals to y. Now, do you think you need to remember this D value? No. What is D value? Average depth of the flow. So as everywhere the depth is same, the average depth is also going to be same. So now I can write hydraulic depth is the average depth of flow section whose sides diverges at top. So that's the meaning of the hydraulic depth. Sir, okay, fine, for rectangle you said like that. If I give you triangle, for example, if this is a triangle, then what is the average depth? See, I told you the depth of flow section means from the top point to the bottommost point. This is the bottommost point. See, in the case of triangle, na, at the center line, the depth is y. But what about here? Is it y? No. But what about at the edges? It is going to be 0 or not? Then what is average? See, whenever I ask you average, na, you just make sure minimum plus maximum by 2. What is the minimum here? 0. What is maximum here? Y. Then what is average? Minimum 0, maximum y. 0 plus y by 2. Which means in the case of triangle, if I saw the hydraulic depth is going to be y by 2. Wait for that. In the next, for the triangle, we'll see that. So, but as of now, what is the meaning of hydraulic depth? It's an average depth of the flow section. So in the case of rectangle, everywhere the depth is y. So D is also going to be y. And what about R? What about R? R is equals to A by P. So R value by B plus 2y. R value is equals to by B plus 2y. So you cannot you cannot reduce this form further. So you have to just keep it like that. Now I'm going to do some special conditions in this. In the case of the rectangle, what is the special condition? The special condition. And these special conditions are very, very important. Wide rectangular channel. In the case of wide rectangular channel where B is much greater than Y, then what is going to be happen? Then what is going to be happen to the hydraulic parameters? See, our point is to look over the hydraulic parameters only. That's it. Don't remember this R value, but you need to remember this D. So now for the special conditions, what is going to be happen? Yes, when B, now what is D? Still A by T, By by B, BB gets cancelled, which means D is going to be Y. Still, whatever the depth of the flow section is nothing but the hydraulic depth. You see, does the form has changed? No. But coming to the hydraulic radius, A by P, By by B plus 2y. Okay. Now, everybody, if you observe this carefully, as B is going to be much greater than Y, as B is going to be much greater than Y, so you can neglect this Y, right? Because width is going to be much greater than Y, you can neglect the Y. Don't neglect the Y in numerator. If you neglect the Y in numerator, then R is equals to 0, which is not going to be possible, my dear. So you neglect the Y value at the denominator, then what else remaining over here? By by B. By by B, and BB gets cancelled, then R value is equals to Y. You see, as the cross section is going to be modified, the hydraulic radius is also going to be modified. Yes or no? What is the hydraulic radius over here and what is the hydraulic radius over here? R is equals to Y. Which means what is going to be happen over here is why R is changing is when you change the cross section, what is R value? What is R? R is equals to A by P, right? The wetted perimeter is equals to changes. When the wetted perimeter changes, then the boundary length changes, then the friction is also going to be changes. Yes or no? I told you in the starting, whenever there is a flow, there is a head loss. And that head loss is due to friction. Yes or no? And in order to find out that head loss due to friction, you require the concept of hydraulic radius. You require the concept of hydraulic radius. So if you want to find out, the head loss due to friction, you require the concept of the hydraulic radius. Because if the cross section is going to be changes, its a wetted perimeter is going to be changes. When the wetted perimeter decreases, hydraulic radius increases. When wetted perimeter increases, hydraulic radius will decrease. So this hydraulic radius will give an account for us to study the head losses due to friction. So for that, I will explain that. So if you remember from Darcy-Weisbach's equation, I hope you remember this. If you have compared to fluid mechanics, fine. Else, you might have saw this equation. HF is equals to FL V square by 2 GD. This is in the case of pipes, right? In the case of the pipes, I hope you have remembered this one. No, you see. So this is the, in the case of the pipes, HF is equals to FLV square by 2 GD. That's for the pipes. Now, in this equation, if you remember, I hope everybody have attended the environmental engineering. Have you? Yes. So if you have attended the environmental engineering, or let it be for the circular pipes, what is the hydraulic radius? So in the case of the circular pipes, R is equals to D by 4. R is equals to D by 4. If you have any doubt, you please go through that R value A by P. So you can find out that R value is equals to A by P. A means pi by 4 D square, by P means weighted perimeter pi D. You are going to get it as R is equals to D by 4. I can write this one as HF is equals to FL V square by, you can write this D as a 4 times of R naught. So 4R and 8GR. Okay. So which means you can observe here HF is inversely proportional to R. What is our hydraulic radius? So I can say hydraulic radius provides information to find head loss due to friction. So hydraulic radius will provide some information regarding to the head loss due to friction, where HF is nothing but a head loss due to friction. F, Darcy friction factor. L is the length of the medium. V is the velocity of the flow, and D is the dia of the pipe. In pipes, this is a. So now I convert that pipe into in terms of R. So when I convert in terms of R, now every equation, see, you can observe every channel has some hydraulic radius. If you know that hydraulic radius, then you can find out the head loss due to friction, can't you? Yes, you can find it out. So what is the significance of hydraulic radius? To determine the head loss due to friction. Okay. So that's about the hydraulic radius. And what about the hydraulic depth? It's an average depth of flow. So what is the significance of the hydraulic depth? So I gave the definition of hydraulic depth. What is the significance? Wait for that moment also. So now I hope you understood. See, my dear, these special conditions are very important. These special conditions are very important. So in the case of the examination, if I am the paper setter, instead of giving a rectangle, I give you wide rectangle. If I give you wide rectangular channel, what is R value? Y. What is R value? Y. And whether it is a normal rectangle or wide rectangle, if it is a rectangle, what is the hydraulic depth? It's average depth. As long as it is a rectangle, its average depth is going to be okay. Now, that's the next one. Second one, triangle. Now, in the case of the triangle, okay. Again, in triangle, let's find out the details. Whatever, this is nothing but the depth of flow section Y, and side slope is 1 vertical to m horizontal. Yes or no? Now you see, if this is a side slope, this is 1 vertical and this is going to be m horizontal, then what should be the incline? 1m, root of 1 square plus m square. This is going to be root of 1 plus m square. Yes or no? Okay. Now listen to me carefully. Array, this is 1 vertical and m horizontal. Yes or no? For every 1 vertical, the horizontal is going to be m. And now for y vertical, for 1 vertical, m horizontal. And if vertical is going to be y, then what should be the horizontal? That is going to be my. That's going to be my. So 1 vertical, m horizontal. Y vertical, my horizontal. And this is also going to be my. So on one side my, other side is also going to be my. Then what is the top width over here? 2my. What is the top width over here? 2my. Now, coming to the weighted perimeter. What is weighted perimeter? See, you know that whatever the solid boundary, the length of the solid boundary is nothing but the weighted perimeter on that, which is simply, this is inclined, right? So how many inclines are there? This is 1 and this is 2. 2 times of the incline. So incline plus incline. Okay. Now you come to this figure, triangle. For 1 vertical, what is the incline? For 1 vertical, what is inclined? Root of 1 plus m square. Okay. Now for y vertical, what is inclined? 1 vertical, root of 1 plus m square. Y vertical, root of 1 plus m square into y. So this value is going to be y into root of 1 plus m square. How many times are there? 2 times. 2y into root of 1 plus m square. 2y into root of 1 plus m square. So that's about the top width and weighted perimeter. And now coming to the area. So tell me the area, please. What is area? Half into base into height. Half into base. Base means top width, right? 2my into height, y. 2 gets cancelled. Area is nothing but my square. See, this channel geometry details are very important. Don't take it as light, because without understanding this, you cannot enter into the classification of the flows and you cannot understand the topics or analysis of the open channel flow. This is very important. So you need to understand how these revisions or area, weighted perimeter are coming. Now, once you know this, I need to find out the hydraulic depth and hydraulic radius. Yeah. Sir, this head loss formula is for pipe flow. Why apply it for open channel flow? My dear student, very good question. Here, this is for pipes, but I can change that dia in terms of hydraulic radius. Yes. Once I change it to hydraulic radius, now this equation can be applicable for anything. This equation, see, once I convert this in terms of R, then I can use this R, because what is our hydraulic radius? Hydraulic radius can be applicable for both the pipes and open channels also. Okay. So now, once we know this, what is hydraulic depth? Please tell me. Hydraulic depth, D is nothing but A. My square by T, 2my. So what is the hydraulic depth? The hydraulic depth is equals to y by 2. Y by 2. So I hope you can understand. I told you this one before solving here itself. I took a small yes. So what is the hydraulic depth definition? The depth, the average depth of the flow section. You see, the minimum is going to be 0, maximum depth is going to be y. Then what is average? 0 plus y by 2. The answer is going to be y by 2 directly. Okay. And what about the hydraulic radius? The hydraulic radius is simply r, my square by p. 2y into root of 1 plus m square. You don't change it much because if you change it also, it's not going to be changed that much easily. So you just keep it aside and you just look over the what is the hydraulic depth in the case of the triangle. What is the hydraulic depth? The hydraulic depth is going to be y by 2. Now I was telling you, if you send the same discharge, the type of flow in the case of a different channels are going to be different. Yes. Now why? I'll ask you one question before going to that. In the case of pipes, means pipe flow, which number is used to classify the type of flow? Which number is used to classify the type of flow? Reynolds number. Yes. Based upon the Reynolds number, you are going to classify whether the flow is laminar or turbulent or transition. But in the case of the open channel flow, which number I am telling to use? I am asking you to use a Froude's number. Yes or no? So where is it, Froude number? Yeah. Yes. So what is a Froude number? Froude number is nothing but V by root GL. Yes or no? This is a Froude number. And where this V is nothing but V, velocity. Which velocity? Maximum velocity or average velocity? Average velocity. Average velocity. So now, my dear, here the point is, whenever we are going to do the analysis, we always go for the average parameters. When we go for the average parameters, then we are going to apply the average velocity. Yeah. So then we are going to apply for the average velocity and average depth. Yes or no? Whatever the flow parameters you take, velocity, average velocity, depth as average depth. And you are pretty sure you know that we are going to discuss about the rigid boundary canals. When I discuss about the rigid boundary canal, what is the only one variable? Depth of flow. So throughout the open channel, if I ask you, the common variable is depth of flow, depth of flow, depth of flow. But in the case of pipes, the dia of the pipe. In the case of the pipe, that is dia of the pipe. But in the case of the open channel flow, that is going to be the average depth. So now if you observe this Froude number, in the Froude number, the velocity is going to be average velocity. And this, what is this L? The L is nothing but characteristic length or not? The characteristic length is nothing but average depth of flow section. What is that? Average depth of flow section. What is L over here? Average depth of flow section. And that average depth is nothing but hydraulic depth. The definition of hydraulic depth is average depth of the flow section, right? So for rectangle, average depth of flow section is different. For triangle, average depth of the flow section is going to be different. So in the case of the Froude number, as a type of channel changes, hydraulic depth changes, the Froude number is also going to be changed. And based upon the Froude number, we are going to classify the flow. See, I told you, Froude number is used to categorize the flow. Sir, how to categorize that? We'll see later, but as of now. So now, let's see. Yes. Now, in the case of the triangle, let's take one more special condition in the case of the triangle. So, special condition for the triangle. In triangle, what is the special condition? Symmetrical triangle with apex angle 90 degrees. With apex angle 90 degrees. Symmetrical triangle with apex angle 90 degrees. So what is the meaning of symmetrical triangle? Symmetrical triangle means both sides, the angle is going to be same, and it is going to be apex angle. Whatever this apex angle is going to be 90 degrees. If it is going to be 90 degrees, and whatever this is nothing but depth of flow, and one side angle is going to be how much? 45 degrees, right? One side angle is going to be 45 degrees. This is y and this is going to be my. This is y and this is going to be my. So now my dear, so if the apex angle is going to be 90 degrees, one side angle is going to be 45, then what is tan 45 here? Tan 45 is equals to opposite my by y. So y gets cancelled. Then what is m value? 1, because tan 45 is equals to 1. So whenever the angle, see, these are some of the conditions that you can expect in an examination. If I give you triangle, most of the time I will go with a symmetrical triangle with apex angle as 90 degrees. So as our apex angle is going to be 90 degrees, one side angle is 45, then m is equals to 1. If m is equals to 1, then tell me, what is area? My square, right? My square. M1, then area is equals to y square. What about weighted perimeter? Weighted perimeter. See, 2y into root of 1 plus m square, right? Keep m as 1. So 1 plus 1, root 2. So 2 root 2 y. Then what about top width? 2my. The top width is equals to 2y. Yes or no? And if you go with the hydraulic depth, what is the hydraulic depth? Hydraulic depth means, tell me, hydraulic depth A by T. Area y square by T, 2y. Y square by 2y. Y by 2. And what about hydraulic radius? A by P. Y square by 2 root 2y. Y gets cancelled. Then y by 2 root 2. So these are the cross-sectional details in the case of the symmetrical triangle with apex angle as 90 degrees. Okay, so these are very, very important. They can ask you match the list of the following, match list 1 and list 2, match list 1 and list 2, especially in the case of ESE, my dear. So they can ask you match list 1 and list 2 for a symmetrical triangle with apex angle 90 degrees. In list 1, they will give you the channel geometry, and in list 2, they'll ask the values in terms of y's. Okay, I hope you understood this. Is there any problem? I hope you people are able to understand the sessions. Yes. If you still has any problem, you please let me know. If apex angle is 90 degrees, you can find it, right? You can find it that if it is going to be 60 degrees, you take 30 degrees. Okay. So I hope you understood this, and now let's come to the next one. Third one, trapezoidal section. If you know the rectangle and a triangle, you can easily say about the. So if you know the trapezoidal section, means a rectangle and triangle, you can go for the trapezoidal directly. So now you can say water table, depth of flow y, 1 vertical to m horizontal, and the width as b. See here how many flow parameters are there, means how many cross-sectional details are there, side slope is there, bed width is there, depth of flow is there, yes or no? So now what is the top width, please? You observe my dear. See, this is 1 vertical m horizontal, 1 vertical m horizontal, then y vertical, this is going to be my, and here it is also going to be my. Then what about this width, b? So on this side, 1 vertical m horizontal means y vertical my horizontal, y vertical my horizontal, remaining is b. So what is the top width over here? Top width means b plus 2my. Top width is equals to b plus 2my. And what about the weighted perimeter? Weighted perimeter means, see, this is inclined I and this is also inclined I. Yes, p plus 2 times of inclined. Okay. So what is b plus 2 times of inclined. So now what is inclined, please? B plus 2 times of inclined is what is inclined? You know that for triangle, right? So inclined means y into root of 1 plus m square. So b plus 2y into root of 1 plus m square. And what about area? Area means area of that rectangle and triangle. What is area of rectangle? See, this is a rectangle portion or not? By plus, there are two triangles. So what is area of triangle? Half into base into height. Half into base into height into 2. 2 and half will go on. So it will be by plus my square. If you have any doubt, you please go through that. So top width the b plus 2my, weighted perimeter and cross section area is there. So once we know this, now we can find out the hydraulic radius. What is the hydraulic radius? Hydraulic radius is a by p and a hydraulic depth is going to be a by t. I'm not going to do anything because if you write also, you won't get any forms like d is equals to y or d is equals to y by 2. Now, after knowing all these things, right? Now, you know the meaning of hydraulic depth, average depth of the flow section. Yes. Now I'll give you how to predict the d value for the trapezoidal section. How to predict the d value for the trapezoidal section. Okay. Listen to this point. This is very important. Again, let's take the trapezoidal. Okay. So this is a trapezoidal section. And now what I'm going to do is, I want to find out the range of the hydraulic depth. You tell me what is the hydraulic depth in rectangle. In rectangle, it is going to be d is equals to y. The average depth of flow is going to be y in rectangle. Do you think that the average depth is more than y? Do you think that the average depth can be more than y? No. And for rectangle already I said the average depth is equals to y, which means for any other channel than the rectangle, d cannot be is equals to y. For rectangle dy means then for any other channel d cannot be is equals to y, and you are for sure d cannot be more than y. So if you take any other channel apart from the rectangle, the hydraulic depth will always less than the depth of flow. The hydraulic depth will be always less than the depth of flow. So for that, what I'm going to do is, for this, so you know, this is the top width. This is the top width. By not changing the top width, don't change the top width. By not changing the top width means, So T is equals to constant. By not changing the top width, you try to inscribe a rectangle and triangle. You try to inscribe, I'm repeating the point. You try to inscribe a rectangle and a triangle without a change in the top width. So if I draw a rectangle, top width should be same. If I draw triangle, top width should be same. So for that, now you see. I'm just dropping the rectangle. I hope you can understand. Whatever the dotted line I am drawing here, this is a rectangle or not? Yes. This is a rectangle of top width to whom? T. Of top width to whom? T. Now, what I want to do over here is, Baba, you know that hydraulic depth means area by T or not? Yes or no? Hydraulic depth means, what is hydraulic depth? Area by T. I am making the T constant. I am making the T constant. So if I make the T constant, for the rectangular section, the area is going to be more than the trapezoidal section. So obviously, for the trapezoidal, the D value is going to be less than Y. Or in other words, you see, the rectangle section has covered a more area. Then obviously, rectangle has a more hydraulic depth. And trapezoidal is inside the rectangle. So for that trapezoidal, definitely the D value is going to be less than 1. So, okay, fine, sir. But sir, is it 0.5y, 0.2y, or more than 0.5y, or more, less than 0.5y? Now, let's see what I am going to do. Now, inscribe a triangle. Top width, T, you keep the top width the same. Now, inscribe a triangle. If I inscribe a triangle, now you tell me the depth of flow is going to be constant or not? The depth of flow is going to be Y. So now, my dear, you see, when I drop the triangle, that triangle portion is inside of the trapezoidal. And when I drop the rectangle portion is outside of the trapezoidal. Or I can say the trapezoidal section is present between rectangle and a triangle or not. So, as the trapezoidal is present inside of the rectangle, D less than Y. As a trapezoidal is present outside of the triangle, D is going to be more than Y by 2. Why? Because you see now, for the triangle, this is a flow area, for that Y by 2. And trapezoidal flow area is more than triangle, then D value is going to be more than. The more the flow area, the more the D. Compared to triangle, trapezoidal area is more. So D value is more than Y by 2. Compared to rectangle, trapezoidal area is less. D value is going to be less than Y. So what is the range? The range is going to be Y by 2 less than D less than Y. Y by 2 less than D less than Y. So this is the range of the hydraulic depth in the case of the trapezoidal. Or you can go for any other section also. So let's say, for example, I hope you understood this. So instead of that, now I will reduce everything. Is because you know that anyways the D value is going to be Y only for rectangle. So if you take any other channel other than rectangle, the D value is going to be always less than Y. So now what I do is, I'll take another example, parabola. So this is a parabola. This is water level, and here it is going to be the depth of flow. Okay. So now what I do is I'll just inscribe see the top width is going to be same. I'll just inscribe a triangle. I kept triangle top width as same, right? So now compared to the flow area of the triangle, parabola area is more area, more D. So obviously D value is going to be more than Y by 2, but D value is going to be less than Y. So the value is going to be y by 2 less than d less than y. So the d value must be in between y and y by 2. Now let's check. If I take d is going to be y. What is the area of parabola? The area of the parabola, I hope you can understand this portion, right? The area of this portion. Area of parabola is going to be 2/3 of the rectangular area. 2/3 of rectangular area, t by y. So what is d? D is nothing but a by t. A by t is nothing but 2/3 of y r naught. A by t. You take this t. So this is going to be 2/3 of y. What is 2 by 3? 2 by 3 means 0.67. 0.67y is in between 0.5y and y r naught. Yes. So for any other channel, always d is going to be less than y. And based upon the triangle inscription, then you can say whether the d value is going to be more than y by 2 or less than y by 2. I'll give you one more thing. Spiral. And in the case of the spiral, this is the spiral section. This is the spiral section. So in the case of the spiral, now you see whatever this is going to be the triangle. So this is a spiral section. Now, whatever this is going to be the triangle, the dotted line represents the triangle. So in the case of the spiral section, the flow area is less than the triangle. For triangle, d is equals to y by 2. As the flow area is less than the triangle, then this value is equals to d is going to be less than y by 2. So what I want to look over here is, you can find out the range of the hydraulic depth by inscribing the triangle without any change in the top width. Don't change the top width. If you keep the top width constant, the hydraulic depth depends upon flow area. More the flow area, more the hydraulic depth. In the case of a spiral, the flow area of a spiral is less than triangle. So d less than. I hope you understood. Now the last topic for today. In the same trapezoidal only. For see, I have given a special conditions for rectangle, triangle, and now for the trapezoidal, I'm giving you the special condition. So the special condition for the trapezoidal is trapezoidal section as half of regular hexagon. Trapezoidal section is a half of regular hexagon. So half of regular hexagon. What is meant by half of regular hexagon? If I can take the trapezoidal as a half of regular hexagon, the meaning of hexagon is all the sides are same. Yes or no? So half of regular hexagon means every side is going to be same. Every side is going to be same. So my dear, the meaning of half of regular hexagon is point number 1. All the sides are going to be same. See, whatever this double dash represents the symmetric. So this is B and this is going to be I. Point number 1, B is equals to I. What is that? B is equals to I. So now, sir, how area is to that? That's basic mathematics, my dear Suresh Kumar. You please go to that. Okay, fine. So in the case of the special condition, trapezoidal section has a half of regular hexagon. If I say regular hexagon, in a hexagon, all the sides are same. And you can divide the hexagon into 6 equilateral triangles. And if this is a half of regular hexagon, then you can divide this into three equilateral triangles. What is the meaning of equilateral triangle? All the sides are going to be same. So now, my dear students, you see, if this is I, this is also going to be similar, this is also going to be similar, then this is also going to be I. If this is I, equilateral triangle or not? What is meant by equilateral triangle? All sides are same. Then this is also going to be I. Then what is the top width? The top width T is equals to 2 times of I. So base width B is equals to I means whatever the sides, all the sides are going to be same. So B is equals to I and the top width is equals to 2 times of I. Okay. And in the case of the regular hexagon, the inner angle is going to be 120 degrees. So the outer angle is going to be how much? 60 degrees. As the outer angle is going to be 60 degrees, now one vertical to M horizontal, this is 60 degrees. What is tan 60 here? Opposite, 1 by adjacent M. So what is M? Tan 60 root 3, M is equals to 1 by root 3. Now apply these conditions, please. If you apply this condition, so come on, first of all, I want to convert everything in terms of dia. So first of all, please look. Yes. What is B? B is nothing but I. What is I? Y into root of 1 plus M square. Y into root of 1 plus M square means 1 by root 3 square. See, 1 by root 3, 1 by 3, 1 plus 1 by 3, 4 by 3. So can I write this one as 2 by B is equals to 2y by root 3. So what is the base width in the case of the trapezoidal section as a regular hexagon? B is equals to 2y times of 2y by 3. This is very, very important. And what is the top width, please now? Top width is nothing but 2 times of inclined. And you know that B is nothing but I. So which is equals to 4y by root 3. What is the top width, please? 4y by root 3. Because once I know the base width is nothing but I, then the top width is equals to 4y by root 3. 4y by root 3. So now, that's it. Once I know the top width, now come into the area. Generally, what is area for trapezoidal? By plus my square. Okay. Now, what is B value? 2y by root 3. 2y by root 3 into y square. So, 2 by root 3 y square plus m 1 by root 3 into y square. Then 3 by root 3, which means root 3 y square. So, what is the area? Root 3 y square. What is the top width? 4y by root 3. Now, area root 3 y square. Then what is remaining is a weighted perimeter. What is weighted perimeter? Come on, tell me please. What is weighted perimeter? B plus 2 times of I. And I can write it as a 3B. I can write it as a 3B because as you know, B is equals to I. So I can write as I is equals to B. So P is equals to 3B. And what is B over here, please? B is nothing but 2y by root 3 into 3. 2y by root 3 into 3. Then this is going to be 2 root 3y. So this is a weighted perimeter. Now I know the top width, I know the area, and I know the weighted perimeter. So now what is hydraulic radius? A by P. What is R value? Root 3 y square by 2 root 3 y. Okay. So now from this I can cancel down root 3, 1 by 1 y. So what is R value? R value is equals to y by 2. After all, the hydraulic radius is going to be y by 2. And whereas the hydraulic depth D is equals to area root 3y square by 4 by root 3y. What is the top width? 4 by root 3y. So 1 by 1y gets cancelled, root 3 will go to the top, and hydraulic depth is equals to 3 by 4 times of y. 3 by 4 times of y. So that's all with this, and these points are very, 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 very important. So what is the hydraulic depth in the case of that trapezoidal section? As a half of regular hexagon, the D is equals to 3 by 4y. You definitely you need to remember these values. You need to remember these values because in the examination they will give you half of regular hexagon. Then you have to get down the area. You have to get down the hydraulic depth. You have to get down the hydraulic radius and all those things. Have a look about this first once again. So that's all with this today's topic, and I'll stop for today's topic. And tomorrow class is going to be So based upon the polls, we got 60%. So tomorrow we'll be taking a 7 to 10. Tomorrow also 7 to 10 a.m. Yeah, I hope you understood this. Please go through this. Okay, I hope we got this. Now I'll be enabling the doubt clearing session in a while. So if you have any doubts, you can ask me there. You can raise your hands. Where is that? Okay. So now people can raise your hands and you can ask me doubts. Shoot out. Mr. Amit, please speak out.
Hello.
Yeah, Mr. Amit, tell me.
Sir, how can we define hydraulic radius? By formula I got it, but
By? I did not get you. By?
how can we define hydraulic radius?
Yeah, that's what I see. You see how whatever the slide I'm showing you, I told you that hydraulic radius is used to provide information regarding the head loss.
Okay. Thank you, sir.
Yeah. Mr. Kalpesh, please speak out. Mr. Kalpesh, please speak out.
Hello, sir.
Yeah, Kalpesh, tell me.
Hello, sir.
Yeah, tell
sir,
me.
as there are fundamental equation, three fundamental: conservation of mass,
Yes.
conservation of energy, and conservation of momentum. And in
Yes,
conservation of energy and momentum, we are using kinetic energy correction factor and momentum correction factor.
Okay. Yes.
So why we are It's correction of mass. Also, we are applying means Q is equal to AV. There we are going to use
Very good. See,
V average.
yeah,
So
tell me,
there
tell me.
also we use any correction factor.
Okay, listen. See, in the case of conservation of momentum, it's not equation m into v average. Okay, that's a formula. Momentum formula is m into v, but the conservation of momentum is net force acting along the direction of flow is equals to rate of change of momentum. That's going to be rho q v square. Okay. Hello.
Yes, sir.
Yeah, whenever the velocity, as long as you keep v as v average, you don't need to apply any correction. But when you use as v square, v cube, then you must have to provide the correction. Hello? The momentum principle
Yes,
says
sir.
that is a force. The force is equals to rho q v square. If you use v as v average, now if for example continuity q is equals to a into v, don't apply anything. But in Bernoulli's principle, velocity head v square by 2g. So there you need to apply because square of average which gives more error. Okay.
Okay, sir.
Yeah. That's why we
In
applied
case of
only.
conservation of moment,
In the case of conservation of momentum, I'm telling you, force is equals to rho q v square. Hello?
okay, sir.
Yeah, that's a v square.
Yes,
So
sir. Got
average
it.
square. Yeah, okay, fine.
Thank you, sir.
Yeah, okay. Mr. Chandrasekhar, please speak out. Mr. Chandrasekhar, please speak out. Okay. Mr. Amit, please speak out. Mr. Amit Court, please speak out. Mr. Amit?
Hello?
Yeah, Amit, tell me.
Sir, you find the range of hydraulic tape by inscribing triangle. I couldn't get that point.
What's
Trapezoidal.
that? You see, I'll tell you one point. You observe this point clearly. What is this?
Hydraulic tape A by
Now, if you see here, for the triangle and trapezoidal, I am keeping the same top width or not?
yes.
If I keep the denominator constant, then the hydraulic depth depends upon whom?
Hello?
If I keep the top width constant, the denominator is constant or not?
Yes.
Then D depends upon whom?
Area.
Area. And you see here, which one has more area?
Triangle.
Huh? See clearly, Ray. There is a trapezoidal, there is a triangle. Which flow area is more? Triangle flow area is more or trapezoidal flow area is more?
Triangle area more, है ना sir?
Triangular. Arey, ऐसे कैसे भाई? You see that clearly? That's the channel now. See, I am showing you both over here. Whatever the water, does the water in trapezoidal is more or water in triangle is more?
Trapezoidal, sorry, trapezoidal.
So trapezoidal area is more means hydraulic depth is more, obviously, yes or no?
Yes.
For triangle, what is hydraulic depth? Y by 2.
Yes.
Yeah. As the flow area of trapezoidal is more than the triangle, obviously D value is more than triangle. So that's the reason why D greater than Y by 2.
Okay, thank you.
Yeah.
Hello, sir.
Hello.
Hello, sir. Is it audible?
Yeah, audible. Who's this?
Chandrasekhar. Chandrasekhar.
Yeah, Chandrasekhar. Yeah, Chandrasekhar. Tell me.
Sir, I want to know what is the physical meaning of hydraulic radius?
The physical meaning of hydraulic radius is to determine the head loss due to friction and to classify the flow based upon Reynolds number. That's what I said, na?
Yes, sir, you said, but sir, ఇప్పుడు హైడ్రాలిక్ డెప్త్ ఉంది కదా సార్, దాన్నే హైడ్రాలిక్ డెప్త్ అంటే మీరు ఏమన్నాడు, మాక్సిమం డెప్త్ ఆఫ్ వాటర్ ప్లస్ మినిమం డెప్త్ ఆఫ్ వాటర్,
యావరేజ్ డెప్త్ ఆఫ్ ఫ్లో.
యావరేజ్ డెప్త్ ఆఫ్ ఫ్లో అయితే మాక్సిమం మినిమం బై 2 చేస్తే వస్తుంది అన్నారు సార్. అలా దీనికి ఏమన్నా లేదా హైడ్రాలిక్ రేడియస్ కి అంటున్నాను?
లేదు, హైడ్రాలిక్ రేడియస్ ఏంటంటే నువ్వు ఏ సెక్షన్ అయినా సర్క్యులర్ సెక్షన్ లోకి మార్చుకోవచ్చు.
ఓకే ఓకే.
And sectional details మార్చుకోవడానికి మాత్రం hydraulic radius. ఓకేనా?
ఓకే సార్, థ్యాంక్ యూ.
Yeah. Mr. Vishnu. Hello, Mr. Vishnu, please speak out.
Hello, sir.
Yeah, Vishnu.
Am I audible?
Yeah, you're audible. Tell me.
Sir, in that triangle sections, how do we get this my? You had written mh and v, no, sir. That's no. How do we get this my?
Okay. For one vertical, m horizontal. Yeah, last one. For one vertical. Okay. And for 1 meter of vertical, m meters of horizontal is there. Okay.
Okay.
For 2 meters of vertical, how many meters of horizontal would be there?
2 horizontal, 2 m.
Listen to me carefully. For 1 meter of vertical, m meters of horizontal is there. Okay. For 2 meters of vertical,
Okay.
how much horizontal would be there? For
2 m,
1 meter,
2 times
2 m.
horizontal.
That's it. For 3 meters of vertical, how many horizontal would be there? 3 m.
3 m, right?
For 5 meters of vertical?
Okay, sir. Why? Okay, okay. I thought it was m by 2. That's
Yeah,
okay.
understood?
Fine, sir. That's all.
Yeah. Oh,
Okay, sir.
yeah. Mr. Maruti Sawant, please speak out. Mr. Maruti Sawant, please speak out.
Hello, sir.
Yeah, tell me.
Sir, why can't we measure the depth from the top in case of average velocity? Like, sir, if we measure from the top or either
Then
from
the equation is changes. If you measure from the top, whatever the velocity distribution equation they have given, na,
yes, sir.
that should change.
If they have not given the velocity distribution equation, then
See, if they don't give, they will give you like in the previous question they have given, na, at 0.2 meters, at 0.8 meters, they have given the velocities, right?
but sir, if you measure either from the top or either from the bottom, that average velocity should be same, na, sir.
Are Baba, average velocity should be same, but from where you are taking the depth. See the distribution, while you are taking the distribution, you are taking from the bottom, the distribution is different. From the top, the distribution is not going to be different, na?
Yes, sir. Yes.
There must be some starting point for a variation, right?
Yes, sir. Yes.
So how we have started with the total velocity? I told you at solid boundary velocity is 0. As the distance increases from the boundary, velocity is going to be increases. Yes.
Yes, sir.
That's it.
And sir, can we define the hydraulic radius like hydraulic depth?
Yeah, that's what. See, hydraulic radius physical significance is to change the sections, any non-circular sections to circular section. You can change that into any you can change that into any non-circular section. To circular section or circular to non-circular section. Okay.
Okay, sir.
In other words, you can write that you can change the section to equivalent rectangle sections also. But you don't require that complex definitions for that. Okay. Don't worry about that.
Okay, sir. Okay.
Yeah.
Thank you, sir.
Yeah. Mr. Jyotiram, please speak out.
Hello, sir. I'm audible.
Yeah, tell me, Jyotiram.
Sir, yesterday my problem.
Hmm.
Sir, in HGL line coincide with free water surface. Correct?
What I did not get you.
HGL line
Yeah.
coincide with free water surface.
Yes.
Piezometric. Sir, I'm not understood the TL line. Why above the HGL? Not understand.
What is piezometric? What is piezometric head?
Piezometric datum head. Sir, bed surface plus datum upper.
Not
Y
bed
plus Z.
surface. Why? What is mean by Y over there? Pressure head plus datum head. Piezometric head means generally pressure head plus datum head. Okay.
Okay.
But what is total head?
What?
What is total head?
Total head.
I'm asking in normal definitions. What is the total head?
Total head means datum head plus pressure head.
Arey bhai, total head means datum head plus pressure head. Is that what I taught you? Is that what I taught you? You see this
What?
one and tell me now.
Huh?
What is total head? You tell. What is total head? You tell me here. I hope you are seeing the
Pressure head
yes.
plus velocity head.
Pressure head plus.
Velocity.
That's it.
And plus datum head.
Yes. What is piezometric head? You see here and tell me.
Pressure velocity head plus datum head.
Arey man, where are you, man? I don't get you. See, I'm showing you the slide. I'm asking you. I have written over here. What is piezometric head over here?
Y plus head.
What is the common definition I'm asking you here? What is mean by P by rho g?
Velocity head.
P by rho g is velocity head.
Sir, yesterday my network problem. This is confused. Network problem, tha na sir.
Okay, fine. If you have network problem, you please go through the notes. I have given the notes also, right? You can download the notes and you can go through the notes. First, you go through the basics first. I have written completely here. What is P by rho g? Pressure head. V square by 2g velocity head. Datum head means Z. Okay. Out of that, P by rho g plus Z. P by rho g plus Z is nothing but datum head. P by rho g plus Z is nothing but piezometric head. Okay. So you can write that total head as piezometric head plus V square by 2g. Am I correct or not?
Yes, correct.
Now, comparatively piezometric head, you see. So comparatively, this is a piezometric head. Yes. Total head is more than the piezometric head or not? By how much?
V square upon 2g.
That's it. That's the reason why total energy line is going to be above hydraulic gradient line. Okay.
Okay. I got it. And sir, another question is in siphon action, sir. Sir, topmost line, it is pressure minimum, na? Siphon pipe.
Yeah. Yes. That's suction pressure.
Minimum pressure.
Yeah, negative pressure.
Okay. This is also called suction.
Yeah.
Suction,
Yes.
Is always negative.
Yes. When it is going to be moving from lower head to high head, it is going to be negative pressure.
Okay. Thank you. Thank you, sir. I got it.
Yeah.
Thank you.
So with this, I am concluding today's session. And if you have any doubts, you please mail to me. It's already 10:20. So because within 10 minutes, the other people has to be attend the next session. So automatically our session will get cancelled. Fine. We'll meet tomorrow, the same time, 7 to 10. Okay, fine.